Hey guys, so in this part of 3.1, now we're going to talk about two unique situations that occur when solving equations. So what I want you to do here actually is I want you to try to solve these two equations, and all I'm going to tell you is that something weird will happen. So I want you to work these out until you get to that point where something seems a little off, and then hit play. Okay, so for this first one, so I'm going to go ahead and distribute. So I get 6x plus 3 plus 4 equals 7x minus 2x minus 6 plus x. And if I add what my like terms on the left side, I get 6x plus 7. And if I add my like terms up on the right side, so let's see, I have 7x minus 2x is 5x plus another x, that's going to be 6x. So this becomes 6x plus 7 equals 6x minus 6. Okay, so from here you have a few different options of how this could go. So I'm actually going to just kind of maybe divide this up so I can show you all the different ways that this could manifest itself. So let me just write this out 3 times. You don't have to do that. You can just stick with whatever you've got, but I just want to make sure I've covered all the options here. Okay, so let's say that in this first option that you're plowing along here and now you decide to subtract off the 6x. So notice what happens here. 6x minus 6x actually just drops out the 6x's entirely. So I'm left with 7 equals negative 6. So let's stop there and let's keep going. Let's try the other one. Another way you could have done this is maybe you kept the 6x's, but instead you said I'm going to subtract off the 7x, or sorry, off the 7, and now I get 6x equals 6x minus 13, and then you subtract off the 6x's, and then you ultimately get that you have 0 equals negative 13. That would be fine too. And in the third option, just another way that you could have done this, maybe you subtracted off the 6x's so they canceled out. So you've got 7 equals negative 6, and then maybe you just plowed on ahead with this and you got 0 equals negative 13. Or you could have also gotten positive 13. That could have also happened, by the way. So all of these are nonsense, right? They don't make any sense. And so the interpretation is actually the important part. It doesn't matter how you got to something that is nonsensical. What is important about this is that you got to something nonsensical, and so then it's just a uniform interpretation. What this means is that there is no solution, which sometimes can be abbreviated with this. So this is the important thing to make sure that you interpret what that actually means. Okay, so now let's go down to the other one. So I'm going to do the same thing. I'm going to go ahead and distribute. So let me do that. Okay, so just double check that you got all those things when you distributed, and now let me collect my like terms. So this will become 13x plus 20, and then on this side this will be 13x plus 20. So this actually has a very similar kind of thing to the last example. So you could have actually stopped here and noticed that each side was the same. That's totally fine. But maybe you didn't, and maybe you kept plowing ahead and you subtracted off the 13x. So then what I get is 20 equals 20. Okay, so that is another interpretation. So I could have stopped here. I could have stopped here. Let me just show you one other way in case you went a different direction. So let's say I've got all this, and oops, this should be 13x. And so now let's say that I started by subtracting off the 20s, and now notice this 20 minus 20 on each side, so those drop out. So I'm left with 13x equals 13x. You could have also stopped here, or maybe you subtracted off the 13x because you're very thorough and you get 0 equals 0. So just to be nice and clear about this, so this would have been fine to stop at and this would have been fine to stop at. So I've shown you all these different ways. So anything with a green star, those are all totally fine ways to get to this. And in this case, this is different from the last one, right? Because this isn't nonsense. This is true, right? 20 equals 20, 0 equals 0, 13x plus 20 equals itself. That's all fine. So the interpretation here is what actually matters. This is what, when this happens, this means that you have infinite solutions. And sometimes people abbreviate that with this fancy R, so you can practice writing that if you'd like. Okay, so those are the next two things that we just want to watch out for. So I just wanted to show you what does this look like from a graphical standpoint. So here's that situation with no solution. So I've graphed each side of the equation, and so you can see, right, these are two parallel lines, so they never intersect. So these are two parallel lines, they'll never intersect. You're always looking for the intersection with two equations. So since they don't, that would tell you that there is no solution. And then if we look at the other example, so this one's kind of difficult to see, but I actually have each side of this equation graphed here. The problem is that the two graphs are on top of one another. So because of that, since the two graphs are literally on top of one another, they are technically always intersecting. So what that means then is that we have that infinite solution here, so all real numbers. Okay, so now let's go through and just summarize the possible solution types for linear equations. So we could have one unique solution, we could have infinite solutions, or we could have no solution. Those are now the three possibilities that we have if we're working specifically with linear equations. So what I want to do now is I just want to give you a few examples to try on your own. So let me show you which ones I want you to try. Let's start with this problem here. 2x plus 5 minus 4x plus 2 equals 1 minus 2x. So I want you to pause the video, try this, hit play when you're ready. Okay, so I'm going to go ahead and collect my like terms. So this will become negative 2x, that's terrible looking too, negative 2x plus 7 equals 1 minus 2x. And then I'll go ahead and I'll add the 2x to each side. And so now I get 7 equals 1. So what is that? That is going to tell me that there is no solution. Okay, so now let me give you another problem. So now you can do 2 times 3x plus 4 minus 6 times all of 3x plus 1 equals 2 times all of 1 minus 6x. Once again, pause the video, hit play when you've got the solution. Okay, so let me just scroll up a little bit here just to give myself a little bit more room. Okay, so I'm going to go ahead and distribute, so let me do that. Okay, so if you're playing along at home here, the first thing I want you to do is make sure that you distributed everything properly. So this should have been negative 18x minus 6. Just double check that or that's going to throw off your solution. So from here now I can collect my like terms. So this will be negative 12x plus 2 equals 2 minus 12x. So you might already notice that these two sides are the same. But if I go ahead and I add the 12x to each side, I get 2 equals 2, so that's the same. So this would be infinite solutions. Okay, and so that really kind of covers this particular section. So I think we will call this video good, and we will move on to the next part of this section. So I'll see you in the next video. Thanks for watching.